Hi, Davey. How are you?
Good.
Good. Get your paper out. We are taking notes. I want to make sure that everyone has these notes today, at the very least. This way, you'll have some tools that you can use when you're doing work on it later. So, Math 1A, Unit 3. This lesson is called Slope and Graphing. That's what it's called in Edmentum. The tutorial and the mastery test, slope and graphing. Okay, so there's going to be a little bit of definition work to do today, and also there's going to be some like actual mathy, what you think of as math class, right? Algebra, solving equations, trying to get a variable alone. So we'll do a little bit of both today. Let's start with some definitions. So what is slope? Slope of a line is basically telling us how steep it is. The slope of a line is a number that tells the reader how steep the line is. So slope of a line tells us how steep it is. And for example, right, here's a couple different lines. Here's one. Okay, cool. That's a straight line. And then here's another one that's a little steeper. And then what if I made one that's almost flat going from side to side, right? So here's three different lines I just kind of made up, and all three have a different steepness. And that's what we're talking about with slope. So we want to be able to describe mathematically and assign a value, a number, to how steep a line is. And that's what we do with slope. Here's another definition for slope, and it's what we're going to use to solve for slope later on. Slope is the rise over the run. So slope is a fraction of these two numbers, the rise over run. And you might be wondering, what does that mean? What does the rise mean? Well, what the rise means in our terms is the change in height. Change in height. And run means the change in like left right, or the lateral change. Like when you watch football or play football, the run is the distance from where the ball started to where it ended at that like play or whatever. So left to right. Let's say the change horizontally. So those are the two different like changes we're going to be looking for in our graphs or with our equations and our points, is a change from two heights and then a change horizontally. Rise over run. So before we move on, I want to make sure you have this written down. Slope of a line tells us how steep it is, and how we measure it. Oh, I'm losing people already. How we measure it is rise over run. So we're going to need to be able to identify change from two heights and a change from two like not straight, but left right distances, horizontal distances. Any questions or concerns, complaints before we move on?
Josiah, I don't have a pen to write this down, so I'm just gonna take a picture and then write it down on my paper later.
You don't have a pen, Tira? You should have told me, and I would have sent you some pens in the mail, or you could come pick them up for me at the school.
Really?
Oh, for sure. If you guys want paper or pens, I want to give it to you. So tomorrow, you're all welcome to stop by anytime. I would like you to give me a heads up so I'll be ready for you. But you can text me or email me, and I will give you all a calculator or pencils or paper for sure, any day.
Okay. All right. So just for now, I'm just gonna take a picture of it, and then later on, if I find one, I'll just write it down
All right.
on my note.
Thanks for telling me. I appreciate that. And the rest
Mhm.
of you should be writing this down. People are still joining. Awesome. All right. Sounds like there's no questions. People who just joined a little late, I want you to check out the video later or take a picture of this because I'm going to move on. The first question is we're talking about slope, slope of lines. The basic premise of slope is it's a number that's telling us how steep the line is. Maybe it's really steep, maybe it's kind of flatter, like a smooth hill. And how we measure it is the rise over run, change in height over change horizontally. Okay, so those of you who are following along in taking notes and taking pictures, let's look at what this means with rise and run. So let's say we had a graph, and I'm not even going to put any numbers on this graph. I want it to be kind of generic. So here's my x and my y axes. And let's say we had our graphed function, our line going through it. I'm going to change my color. Something like this. Here's my line. This purple line, this dark line, this is our function. And this purple line is what we're looking to find the slope for. So when we say the rise and the run, here's what we mean. Any 2 points you can use to find slope. So let's say I use these 2 points right here. Remember, for this example, I'm not using any numbers. We're just examining what it means to find the rise and the run. So the change in height means looking at point number 1 and point number 2. What's the change in height between those two? We're looking at the straight up and down, straight vertical distance or difference, right? We're looking at how high is this? This is the rise. And then likewise, to find the run, I'm looking at the horizontal lateral difference. Remember, if this was a football that started at point 1 and went to point 2, then I'm wondering how far right did this thing travel right there. So that distance is my run. We're going to be doing this today where we have 2 points, 2 coordinates, remember, x's and y's. Those are my 2 points, and I want to measure the rise between them, like the change in height, and then the run between them, the left-right difference. So that's what we mean by rise and run. So we'd have to find those 2 numbers and then put them together into this little formula. Let's write it again. I can't stress it enough how important slope is to us in Math 1. Rise over run. You all have your mics off, so say it with me right now. Rise over run. Say it out loud. Don't say it in your head. Say it out loud. No one else can hear you, right? Your mic's off. Rise over run. Slope is rise over run. I want you to. Oh, Victor, high five to you, dude. Boom. Do it again for me if you don't mind, unless you don't want to.
Rise over run.
Victor, I want to give you something. I wish I could give you something just for taking a risk and turning on your mic. Rise over run. I want you to memorize this. Slope is rise over run. All of you, I hope, are memorizing this. Rise over run. It's very important for us in Math 1. If we're going to get any tattoos this year, let's tattoo slope is rise over run. Maybe somewhere on your arm so you can use it later on a test. Seriously. I mean, I'm kidding. I'm not telling you to get a tattoo. But if you were to, this is what I want you doing. Rise over run. Let's try an actual example with numbers. Here we go. So I'm going to make a graph real quick. Bear with me. And you know what? Tira said she's taking pictures. I want all of you to save some time and some stress Don't bother copying this down. If you want to take a picture of what I'm doing, you can do that. And I'll tell you when I'm done. I'm going to make a little graph. We've practiced making our graphs in the past. So I'm just measuring out like the same space between my numbers, trying my best to make it close, but it's okay if it's not perfect. Okay, so let's stop there for now. Remember, this is the x-axis is horizontal, and the y-axis is vertical up and down. Um, let's see. Don't take a picture yet if you're doing that. Let me put some points on here. So far, all we have is a blank graph, a blank plane. Okay, so I'm going to put my first one right here at 1 comma 2. Make it nice and big. That's my first point. And let's say we had a second point over at, how about 7 comma 5? So that's 7 to the right along the x and then up to the 5 high right here. Okay, now people taking pictures, you can go ahead and take your picture. Let's label this 1 comma 2 and 7 comma 5. So what have we graphed? We've graphed 2 points. Doesn't look like a line, right? But all we need to have a line is 2 points. If you have 2 coordinates, 2 points, if you connect them, you're making a line. So let me do that now. And I'm going to try to go out past it like this. Cool. And guess what? If it's not perfect, it's okay. I want you to not spend so much time. I know a lot of you, I know it, are worried about making graphs perfect or making it like correct. And that sometimes can be debilitating if we're worried so much about making it perfect or making it the best. Um, what's in, that's not what's important. What's important is just trying, getting practice. And when it's not perfect, just roll with it. It's okay. Mine's not perfect, and I think it's going to be good enough just to practice our slope with. Let's try finding the slope of this red line. So we do need to know where it lives. I do need to know these numbers. 1 comma 2 is on my line and 7 comma 5. So we want to find rise and run. Remember, I'm going to write it again. Slope is, that's equals, rise over run. Slope is equal to rise over run. So I need to find the change in height between my 2 points. And I got to find the lateral horizontal change left right between the 2 points. So let's start from the 1 comma 2, this guy on the left. And I'm kind of just measuring upwards, straight up. How high do I go before I reach the height of my other point? So I'm kind of using my finger, right? I'm going to pretend I'm doing this on Admentum or on paper. And I am trying to measure how high up until I get to that spot. So I think it's right here. And then I look over to the right. Sure. Yeah, I picked the right height. Good. Plus, another clue is in the coordinate 7, 5, right? The 5 means how high it is. That's the y. How high, right? How high, its location height wise. So basically, I know, okay, it should go up to 5. So looking at my vertical line again, how many units is that? It starts at 2, 2 high, right? And it goes up to 5. So how many units? It's 1, 2, 3 units. So my rise is 3. The rise from these 2 points is 3. It goes up 3 squares or 3 boxes, 3 units. Yeah,
Um,
question.
should I take a picture of this too, or
Yes, take a picture of
okay?
this too. And then we're going to do the run in a second. Take a picture of that as well. And then you'll have all three, the beginning and then finding the rise and finding the run. Is that okay?
Yes, sir.
Good thinking. Good thinking. Stop now and take a picture, everybody. And now I've already made kind of a triangle here with my dashed lines. So let's use that other part of the triangle, the flat part, horizontal part, to measure the run. Because that's going from my point number 1 to my point number 2, isn't it? Just like earlier. So starting from right here, going to the right, how many boxes, how many squares, how many units is that? So we can use the ruler below in purple. It starts right here and it goes to the right. So 1, 2, 3, 4, 5, 6. And it doesn't pass that, right? I'm looking to measure that point, the coordinate. So how many was that? That was 6. So my run is 6. Excuse me. So we had to measure in two parts, right? The rise and the run. Oh, we got the numbers though. So finally, folks, we can find the slope. Slope is rise over run, which is 3 over 6. We just found those numbers. So our slope is 3 over 6, 3 6. Now, it looks like this fraction, 3 6, can be reduced. Anytime a fraction can be reduced, we always want to do it. We want to show the cleaner version. So I'm going to reduce my fraction by dividing 3 on the top and on the bottom. And it looks like our slope is actually 1/2, 1 over 2. Take another picture and let me actually box this. So we found the slope of this line using rise over run. But we had to know, well, what are the actual locations of some of the points on this line? We used 1, 2 and 7, 5. But measuring the rise and the run will work for any 2 points. It doesn't have to be any special ones, just any 2 points on the line can be used to measure slope. Any questions, concerns, please? Okay, before we do anything else, I want to see people taking notes. So if you're taking pictures, show me your phone with one of those pictures that you just took. If you're taking notes, show me your notes real quick, like this. I want to make sure you guys are following along and not taking a nap while we're doing our slope graphing. So can anyone show me your notes? I'm not seeing anything yet. I know. Oh, there we go. Levi, I'm sorry. Thank you, Levi. And Tira's got some pictures. Good, Tira. Savannah took a picture. High five, Savannah. Is that it? Well, I wish I could give candy to those three. Anyone else? All right. Then you know what you need to do right now, if you haven't done it yet, is take a picture of this page. I'm going to get my thing out of the way.
I'm holding. Yep.
Sorry, Anaya. You're a little choppy. I'm sorry. Go ahead and chat me.
I was saying.
Oh, Anaya, I see that. Thank you. Thank you. All right. Thank you to all of you, Levi, Savannah, Tira, and Anaya. If you haven't already, take a picture of this page. I'm going to move my thing out of the way. And then we're going to move on and look at some more slope problems. And with your mics off, go ahead and say it again. Victor did it earlier with me. Say it out loud. Slope is
Slope is rise over run.
Was that Tiara?
Slope is rise over run.
Yes.
Levi, yes. Thank you both. With the mics on too. All right, we're doing it big. All right, you can be embarrassed of me. That's fine. Let's move on. Let's do another problem. Okay, here we go. Slope can be positive and it can be negative. Remember, slope is a number. We found in our last example, it was 1/2. So when we're talking about slope, we're not talking about a variable like x or y. We're talking about a straight up number. And it can be a positive number or a negative number. If it's positive, that means our line is going upwards from left to right. If it's negative, it means our line is going downwards from left to right. Downwards. So if you're given a picture, without even measuring the actual number, we should be able to tell if it's a positive or negative slope right away. If it's going upwards, like remember, our little here, come back to my pictures with me. There's always a little person, imagine, walking up or walking from left to right. Okay, they're walking rightwards. So I'm going to put my person on both of these lines walking rightwards. So if they're going up, that's positive. If they're going downwards, like downhill, that's negative. They're always going from left to right. That stays fixed though. Just like how we read from left to right, our lines are moving from left to right. Let's try finding slope without the picture. See what that looks like. Okay, so let's call this example 2, because we did example 1 when we found that slope of 1/2. So example 2, find the slope of the line that goes through the points here we go, drum roll please, 2, 7, and 5, 3. 2, 7, and 5, 3. So they're not supplying us with like a nice graph this time where we can count the units, count the squares to find rise and run. But we are still going to use the same idea of rise divided by run. So let's go back to that. Slope is rise over run. And we know that means the change in height over the change in distance, the lateral horizontal change. We also know that when we have two coordinates like above, 2, 7, 5, 3, these stand for x's and y's. The first number, remember, that's our domain numbers. Those are the x's, and then the y's are our height range numbers. So we can find rise by subtracting one y from the other. So back down in the middle of the screen again, rise over run. Well, how can we measure that without the picture? We can subtract one y from the other y. And how do we measure run? Well, that's the same thing. We're subtracting one x from the other x. The only caveat or really important point here is that the x and y's that are above each other in my formula, they have to come from the same point. So let's fill that in below. So y minus y, let's do 7 minus 3. I'm looking above at my two coordinates. 7 is one y, minus 3, the other y. 7 minus 3. Y minus y, that'll give us the rise. Then below, I want to do x minus x. So I have to label those in the same order that I did my 7 minus 3. So I would do 2 minus 5 because 2 came with 7. Those should be together. And then the 5 and 3 should be together. So for rise, we're doing 7 minus 3. For run, we're doing 2 minus 5. Now we have to just clean up the top and the bottom separately. So 7 minus 3, that gives me 4. 2 minus 5, 2 minus 5. Side work. 2 is positive. 5 is negative, minus 5.
It'll be -3.
It'll be -3. Very good. Who was that?
Tiara.
Tiara, thank you.
Sorry, my voice.
Now you got the voice issue like me? Yeah. Well, thank you for helping me and sharing. Yeah, if we were to do them as the battle model, +2 here, -5. Each plus cancels a minus, or each minus cancels a plus. We're left with these three, -3. So that's where Tiara got that, or one way that you could get that. So here's our slope. -4/3. Since one of the numbers, the -3, was negative, how we deal with that is make the whole number negative. Like let me back up. Maybe I should have done this. Just one moment. I'm going to change something, but we'll end with what we had. So we had a -3 in the bottom, right? Well, that single negative sign, that basically kind of takes over for the whole number. So continuing to the right, instead of writing it as just the denominator negative, I write it as the whole fraction negative, like that. And there's our slope. So we can find slope if we only have 2 points. Essentially, what's happening is we're still counting units, but we don't have the graph in front of us. So we have to do the subtraction. One height minus the other, one x distance minus the other x. Let me
So just say I had a question.
Yeah, go for it.
So when we do -3 on the bottom, we're doing negative like the whole fraction?
Correct.
Okay.
Correct. It's not, and that's not just a slope thing, that's for all fractions. So if we had negative on top, if it was like side example over on the left here, -4, here I'm going to box it for a side example. If we had -4/3, well, that negative is like the whole number being negative, not just the top or bottom. So I'm going to convert it to like the whole thing, -4/3. Either way, if that ever pops up again, and it will, good question, Tara, because it will pop up again. We'll see it again where either the top or the bottom is negative. That means the whole thing is negative. I think that's it for this page. Any other questions right now? Concerns? All right, no questions. Let's see. We did this. We did this. You know what? While we did this, let's try another one. Let's not let this go away. Let's try one more the same style. So if you're given 2 points, so example 3, given 2 points, find the slope. Often the instructions are just like I wrote it on example 2. Find the slope of the line that goes through the points. Find the slope from the 2 coordinates, the 2 points. So here's 2 points for example 3. -1, 8, and 4, 18. So we know, and let me put our directions here. We want to find the slope between the 2 points. Or 2 coordinates. Okay, so lots of different ways to word these problems, but it's asking us to just find the steepness, the slope, between those 2 locations, those 2 coordinates. So we go back to our trusty formula, which we've all been saying all morning together. Slope is rise over run. Slope equals rise over run. The rise is the change in heights. So y minus y. And the run is x minus x. So now I'm going to plug in numbers for those y's and x's. We also know back from unit 2 that the first number is always the x and the second number is always the y. So let's do 8 minus 18. I like to just do them the way they are given to me. 8 minus 18. Below that needs to be negative 1 minus 4. Okay, this is tricky. Lots of negatives. But we're going to tackle it one part at a time. So just looking at the numerator, the top, 8 minus 18.
Negative.
You cut off. What was that? Negative.
Sorry, negative 10.
Don't be sorry. Was that Anaya?
Yeah.
Awesome, Anaya. Thank you. Negative 10. And in the denominator, this one's tricky because they're both negative. Negative 1 and a negative 4. Negative 1 minus 4. If we use my battle analogy, go ahead.
Sorry.
No. What do you got?
Negative 5.
Negative 5, yeah. My negative 1, 4 negatives all together, nothing cancels. It's negative 5. Very good. Okay, so we've got negative 10 over negative 5. Now this time, the top is negative and the bottom's negative. So it's not just one negative number because we've got negative divided by a negative. So we can kind of use that other math rule from early in our careers, which is negative divided by negative becomes a positive. So in this case, folks, it canceled. Negative on top, negative in the bottom, cancels out. Just like anything divided by itself becomes the number 1. They cancel. Okay, and then 10 over 5. Well, this is our slope, but we can simplify this. 10 over 5 actually comes out to 2. 10 divided by 5 comes out to 2. So we may have a whole number for our slope. In this case, our slope is the number 2. Because our fraction kind of disappeared, right? It canceled through the division. Doesn't always happen, but it can. Also, by the way, this is positive 2. So that means we know that our line is going upwards from left to right. Just a little side note.
I have a question.
Yes.
So, since this is just a 2, but it would be, since it's still a slope of rise over run,
Yeah.
would it be like an imaginary one as the run, or like?
Absolutely. Good. Yeah, you are on it. I wish I could. It's like I paid you to say that. Let me just riff on that. Slope is 2. There's no fraction there, so there's no rise over run. And who was that who just said that? Was that Anaya? I'm sorry.
Yeah.
Awesome, Anaya. Yeah. So we put an imaginary 1 underneath. Remember, 2 is the same thing as 2 divided by 1. If you times 1 to anything, it doesn't change it. And if you divide anything by 1, it doesn't change it. So 2 divided by 1, check it in your calculator if you don't believe me, is still 2. So these are mathematically equal to each other. So to make it a rise and a run, we would write a 1 underneath it. So any whole number, let me write this out as one of our rules for today. Any whole number slope, like 2, put a 1 underneath it for its run. So if we're trying to graph it using its slope, we haven't done that yet, but if we're trying to graph it using its slope, we know that it's a 2 for rise and a 1 for run. Now, we're not going to write it like that in our answers, though. In our answers, we're going to clear out the fraction, clean it up. So if we wrote this out, we would say just the whole number. Slope is 2. So in Edmentum, it's never going to have a 2 over 1. It'll clean it up. In Edmentum or our work, we're going to clean up those fractions, but we know that it's like a secret 1 underneath, basically. Good question. Okay, darn it, it's already 2:40. Let's try, I want to throw in another concept today. We've talked about slope. I also want to talk about the x and y intercepts. Okay, this is kind of a side topic, kind of a different topic, but it does go with slope. They're kind of like related, they're cousins, but they're not exactly the same. X and y intercept. Now back to football. I'm honestly not really into sports that much, but I know in football, one of the terms they always use is interception. When one team basically takes the ball from the other, they're kind of like a wall that the ball got stuck at, right? And it was intercepted at a certain location. That's exactly the same thing in math. We're looking for where the line is intercepting the x and y axes, where the line is intercepting the x and y axes. All right, so let's just draw a picture to make a example. So here's another generic XY plane, XY. And in purple, I'll put my line in there again. Here we go, another nice positive slope line. Well, where the purple line is crossing or intercepting, right here and right here, these are my two intercepts. The one on the y-axis is the y-intercept. And likewise, the x-intercept is down here on the horizontal. All right, go ahead and take a picture, or if you're writing, I want you to copy this page down. We need to be able to find the x and y intercepts on the picture and just given the function equation, both ways. So just like with slope, I want to be able to measure slope using our picture like earlier and using our formula y minus y over x minus x. I also want to find the y and x intercepts the same way. When it's a picture, it's not too bad because we should be able to locate the numbers on the line. Let's try an example of that. Example 4. Find the x and y intercepts of the function. Now remember, function, which we've been working with in the last unit a lot, the line we're given is the same thing as the function. So you're going to see that a lot. They're going to refer to it as a function and it's actually like a graph, or maybe they'll give you the equation and they refer to it as find the slope of the line of this function. And it's like, where's the line? Oh, I got to find it using my equation. Anyway, so here's my first example of x and y intercepts. Again, I don't expect you guys to do this perfectly, but I just want you to give it a shot, making graphs with me, just like I'm doing it. So let's say, and if you're taking a picture, that's okay, but try to do it by hand. It'll be good practice. So let's say we had a point at 0, 5. So that would be right here. And we also had a point over at 4, 0. 1, 2, 3, 4. Okay, so I know I kind of built it this way, but here's my 2 points. I'll connect them to make our actual function or a line. And it's pretty fast, I think, to find the intercepts when we're given a picture. As long as we can tell where it's crossing, it's kind of telling us the answer. The y-intercept is 0, 5, or just y equals 5. And my x-intercept, I look down there where it's crossing the horizontal and it's crossing at 4. So my x-intercept would be x is equal to 4, or they may say it as a point, 4, 0. That's the x-intercept. Now, one thing I want you folks to notice before we move on is anytime we're dealing with x and y intercepts, look at those coordinates. What's common between the x and y intercept coordinate? Is there something the same between those two?
I'm sorry, what was the question?
But yeah, sorry, maybe I'm asking it weird. Thanks, Tira. The question is, looking at the two coordinates for the y-intercept and the x-intercept, what is the same or what is common between those 2 points we found? Is there anything that's the same? What I mean is the 0, 5 and the 4, 0.
I think the fact that they're both at 0.
They both have a 0. Levi, thank you. I'm sure other people probably saw that same thing Levi said. You might have even been thinking he can't mean that, right? The 0. I do. The 0 is what's important. So if we want to find x and y intercepts, we know that for one of them, the 0 has a 0 for the x or for its domain, and the other one has a 0 for its y or its range. See that? Basically, the 2 points on the line that have zeros for x and then for y, those are the intercepts. This is going to be useful if we don't have a picture and we're supposed to find intercepts. Let's try that now. Let's say we were given an equation like this. Example 5. Find the intercepts, not the slope. Find the intercepts of the function. And here's our function. They're giving it to us as an equation, 3x plus 10y equals 30. Excuse me. So what I was hoping that you would see from the picture is that the 2 intercepts always have zeros One of them has a 0 for x, the other has a 0 for y. So to find intercepts using the equation, we plug in 0 for x. I'll write this on the side. Here's kind of our instructions. Plug in 0 for x, and then solve for y. And likewise, below, to find the other intercept, we're going to plug in 0 for y. Oops. For y and solve for x. Okay, it's kind of a two-step process. So let's try that. I'm going to draw a line. It can separate my work and my notes. Let's start by plugging in 0 for x and solving for y. So I go to my equation at the top. I'm going to switch out or substitute 0 in for x. So see how my x just switched out to a 0? But the rest is all the same. Plus 10y equals 30. 0 times 3. I'm hoping you remember at this point, 0 times anything is 0. So it kind of knocks out that 3 altogether. We just cross it out. We're left with 10y equals 30. Solve this mini equation for y. It's 10 times y. How do we undo timesing? Dividing. Division, yep. So we're going to divide both sides by 10, and we get y is 30 over 10, 3. So my y-intercept is y equals 3. Or, remember, what did we plug in for x? We plugged in 0. So we know that 0 is x and 3 is y. So there it is in two different forms. Stated, y is 3, or as a point, it's 0, 3. We plugged in at 0 for x, we got out 3 for y. Now we start the whole process over. And instead of plugging in 0 for x, we're going to plug it in for y. Okay, this time it knocks out the 10. Goodbye, 10. And we have 3x equals 30. Divide both sides by 3. And we get x is actually 10. 30 divided by 3 is 10. So there's our x-intercept. And if we wanted to write it as a point, we plugged in a 0 for y. And we have 10 for x. So we kind of solved it backwards. Usually we plug in for x and solve for y. But we plugged in 0 for y, we solved it, and we got x is 10. So our y-intercept first, and then secondly, we found the x-intercept. So we haven't learned anything about slope in this problem, but we do know where the line is crossing over the axes. So we can make a sketch of this if we needed to. We know that it's over at 10 on the x bar, and it's up 3 on the y bar. And if we connected those two dots, we can draw our line pretty fast. Excuse me. Okay. All right. It's almost 12. Darn it. I guess let's stop there today. So let's see your notes one more time, please. Your newest notes.